Let's talk about the problem with the obliquity. Earth's obliquity is the tilt in its rotation so that it doesn't quite rotate in the same plane as the rest of the solar system. This difference means that places away from the equator face toward or away from the sun at different times of year, giving us our seasons: winter, spring, summer and fall or autumn. Let's talk about this in this you think about the rotation of a planet and the rotation of the solar system. There's a tilt between the two in effect. They're not quite in line, so that difference is the obliquity. And that therefore means that our planet doesn't actually spin quite in the plane of the solar system, but at an angle to it. Early in the history of our solar system, many planets suffered collisions with planetesimals, which left enormous impact craters, asteroid fragments, changed obliquities and altered spins. This left Earth with a 23.4 degree obliquity, which means that life on Earth has evolved to survive with this. Additionally, Earth's tilt or rotational obliquity has been stabilised over lengthy periods, billions of years, by the presence of our large moon, without which Earth's obliquity could vary enormously. Plants and animals use the seasons to time their lives, including plant respiration, animal breeding, migration, feeding and hibernation. Any planet which we might consider terraforming would need to have a similar obliquity for life from Earth to survive. Mars, probably our first terraforming target, has two small moons which are not large enough to stabilise its obliquity, so that although it currently has a similar obliquity to Earth, it has varied in the past from 0 to 60 degrees. Although moonless Venus is stabilised by its heavy atmosphere, it's actually spinning in the opposite direction to the rest of the planets. Therefore, from our own immediate planetary experience, it is possible to stabilise the tilt of a spinning planet by either having a heavy atmosphere or a large moon. If large moons are key to stabilising obliquity, objects in the asteroid belt have been suggested as possible moons to stabilise Mars' obliquity. Planets without seasons could have uniform conditions throughout the year, so if the planet rotated in exactly the same plane as the solar system, it might have constant rainfall in one area and constant sun in another. This would make life hard in both locations. However, the climate of a zero obliquity planet could include far more glacial ice than a planet with even a moderate tilt. This is because any snowfall could never be melted by a summer that never came. Equally, planets with high obliquity would be hostile to life because each pole would face the star for months of the year, resulting in months of constant daytime heat wave followed by months of freezing darkness. Rapid changes in a planet's obliquity might not deprive it of life, but will almost certainly deprive the planet of complex animal life. Thus, before we can add life from Earth to a planet, we must have a nice stable Earth-like obliquity. Mars is easy as it already has the right obliquity and needs little more to be done apart from warming the planet and adding an atmosphere and water. However, scientists are still uncertain whether Mars' obliquity will be stable in the long term or not. If it is deemed to be insufficiently stable on human timescales, a larger moon will be needed. This could be the amalgamation of the existing two small moons, Phobos and Deimos, but a larger moon might need to be created by adding an object from the asteroid belt or a moon from one of the outer planets. The material in the asteroid belt may not be massive or common enough to construct a large moon. One additional issue here is that Phobos and Deimos are much closer to Mars than our moon is to Earth. Therefore, they may need to have their orbits changed to ensure the correct degree of obliquity stabilization is achieved. There are two possible ways to change a planet's obliquity. The first is asteroid impacts. The obliquities of Mars and Earth are believed to have been set by impacts early in their history. Finding asteroids which could be used as impactors to change a planet's obliquity is limited by the range of objects in the asteroid belt and by their value as mining resources. However, if a number of smaller impactors are needed, they might be sourced from either the asteroid belt, Jupiter's Trojans, or the Kuiper belt. Another limitation is that the change in a planet's tilt needs to be constrained close to 23 degrees, and a change in rotational motion should not be induced unless the length of the day needs changing. This is complex, as the planet is already rotating and we do not want to initiate a complex tumble. It's also possible that moons could be created by glancing impacts in the same way that Earth's moon was created. However, this may be a very slow approach, as the material ejected into orbit is likely to be molten and might take millions of years to cool. Once an obliquity of approximately 23 degrees has been attained, a large moon may be needed to stabilise this. The source of this moon is similarly constrained by the value, size and rarity of asteroid belt objects, so either a moon from one of the outer planets or the Kuiper belt might be needed. Earth's moon is very unusual due to its size in relation to Earth. Only the dwarf planet Pluto has such a proportionally large moon. Therefore, a relatively large object would be needed to duplicate our moon's obliquity stabilising effect. The other approach to changing an obliquity is momentum transfer. It might be possible to use objects from the Kuiper belt or the asteroid belt to transfer angular momentum from a gas or ice giant by tight turns around the planet needing tilt correction and the giant planet. However, an asteroid intended as an angular momentum transfer vehicle might come within the Roche level of either planet and be destroyed in the process. That's the breakup point. One possible solution would be to follow a path around 3 rather than 2 planets to limit the tightness of its turns. If the object transferred much of its momentum, it could be placed into a stable orbit around the planet as a moon, which might stabilise the obliquity once it had been corrected. Any terraformed planet without seasons would be hostile to most life from Earth, as animals and plants would not know when to perform critical functions. They would mistime their lives and fail to breed, not get enough to eat, or lose contact with each other. This includes domesticated animals and plants important for human survival. In other words, we're better off finding planets which have the right obliquity to start with than trying to mess with the process, which is going to be very, very hard. Thanks for listening. Bye.